In this video, I'm going to give you some tips for post-lab 1 enthalpy and entropy. In this experiment, you had 3 different solids that you dissolved in water and you monitored the temperature change during that dissolving process. So in this first data table, you're going to have temperatures that you reported while you were doing the experiment, initial and final temperature for each, and then you'll begin by calculating the delta T for each one of these solutions. Remember that delta T is always your final temperature minus your initial temperature. And if that gives you a negative number, then you need to be reporting a negative delta T in this box. So make sure that you're respecting the sign of delta T, whatever it ends up being. In the last column here, you are going to classify each one of these processes as either exothermic or endothermic. So as a reminder, an exothermic process is one where heat is exiting or leaving the system. So this is where heat goes out of the system. And that would mean, you go imagine like a bonfire. That would mean that this is something that feels warm if you touch it because heat is leaving the system. And then endothermic is the opposite. Endothermic is where heat is coming into the system, and so that means that it is one that would feel cold if we touched it. So you can compare your temperatures, or you could look at your delta T and decide if you were touching this, would it feel like it was getting warmer or would it feel like it is getting colder? So I'm going to change this or add this to say that it is one that gets warmer. An exothermic is a reaction that gets warmer. So looking at your initial versus final, if the solution is getting warmer, then that means that it is exothermic, that heat is leaving. Once you get that figured out, you're going to go down to your second data table. This is asking you to fill in just this sign of delta G. So that means that it is either going to be positive or negative. You're just going to be writing, is it positive or do you think that it is negative? Or you could write the words if you wanted. Now for delta G, remember that delta G is an indication of spontaneity. So first thing that you want to do is think about whether each one of these processes were spontaneous or not. The definition of spontaneous is that the reaction happens with no additional help. So you have to ask yourself, did you have to help that NaCl dissolve? Did you have to heat it up? Did you have to add a catalyst? Did you have to do something to get that to dissolve? Or did you just have to simply put it in water and then ta-da, it dissolved? If all you had to do is just drop it in there, that means that it is spontaneous. So you're going to look up what is the sign for delta G if a process is spontaneous. Look that up in your notes. If you decide that this is spontaneous, meaning that you didn't have to help it, it just did it all by itself, then you are going to assign the sign of delta G that corresponds with a spontaneous process. And that's how you'll fill in this column. For delta H, the sign of delta H, again, this means you're either going to be entering positive or negative. You're just putting in the sign, not the value. For that, you are going to be basing that off of the classifications that you made in the first data table. Is it exothermic or is it endothermic? So for this, you might have to go back into your notes from Chem 162. What is the sign for delta H if a reaction is, we'll just say exothermic? What is the sign of delta H if exothermic or endothermic? You can use either one. And so we'll say if up here you classified the NaCl dissolving process as exothermic, then you'll use that information to help you decide if it's a positive or negative delta H. Now, when you get that last data table figured out, you're going to go to the next page to answer some questions or answer a question about each one of the 3 different solids. So for the first one, we're going to be focusing on NaCl, and it says use the sign of delta G and the sign of delta H. This would be what you predicted in this data table right here. Use those signs and also use this equation to predict the sign of delta S for the process of dissolving NaCl. So you're going to be basing this off of this equation right here, and you're just gonna say, well, let's just say that I decided for NaCl that the delta G is always a negative number. So I'm just going to put a negative in here in parentheses. And I decided that the delta H is always a positive number. I'm just going to put a positive in parentheses. So in order for this equation to be mathematically accurate, in order for me to get a negative number over here for delta G, and it doesn't matter what the value is, all that matters is that it's a negative number. What does the sign of delta S need to be in order for all of this to be true? Keep in mind that in this equation that we're the delta G equals delta H minus T delta S, the temperature is going to be in units of Kelvin. So that means that the temperature is always going to be positive all of the time. So you could even fill that in if you wanted. The temperature is always going to be positive. So what does the sign of delta S need to be? Is it a negative number? Is it a positive number? Now we have something like this in class, in lecture, this sort of analysis or this sort of process. So if you're struggling with like figuring out how to make all of this work, you can look at the videos for the lecture, look at the notes, and try to make a decision that will probably give you some more information to help you make a decision about delta S. You're going to do the exact same thing for NaNO3. So you're going to look at your data, you're going to plug in the sign that you predicted for delta G, plug in the sign that you predicted for delta H. T is always going to be a positive number. Make a prediction about delta S. Like I want to get rid of these because I just made those up and I don't want to be confusing anybody about those signs. They may or may not be wrong. I just randomly made them up. So same thing down here, just plug in your signs. Delta T is always, or T is always positive, and make a prediction about the sign of delta S. And then you'll do it one more time for NaCH3CO2. Now this one's going to be a little bit trickier. You'll see there's some more words on here. So this one is saying use the sign of delta G and the sign of delta H. I'm going to copy this equation again, to establish conditions for temperature and S. For example, what type of temperature, high versus low, this is always going to be a positive number. What type of temperature is necessary for delta S to be positive? What type of temperature is necessary for delta S to be negative? So your answer here is going to be something like delta S is positive when the temperature is, and then you're going to choose high or low. Delta S is positive when the temperature is high. Delta S is positive when the temperature is low, based on what makes sense in the math equation. And you'll do the same thing again. Delta S is negative when the temperature is high or low. And again, this is a pretty complex concept. You definitely want to be looking at the lecture notes, where this is, all of this stuff is going to be covered in more detail in the lecture material. But hopefully this is enough to kind of get you started, get you pointed in the right direction.